Now in this video let's see the properties of determinant. So the first property is if two rows or two columns are identical and proportional, then the determinant will always be 0. If two rows or two columns are identical, so here row number 1 1 2 3, row number 2 1 2 3, these the elements of row 1 and row 2 row 3 are same, so the determinant of this matrix will always be 0. Similarly, if two rows or two columns are proportional means here see first row is 1 2 3. If I multiplied 2 in 1, 2 into 2 into 3, I can get the second row. Like 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6. So these two rows are proportional to each other. So in such cases, the determinant value of this matrix is always 0. So this is the first property. If two rows or two columns are identical, the determinant is 0. If two rows or two columns are proportional, the determinant is 0. Now in second, if all the elements of any row or column is 0, then the determinant is 0. Mm, So if there is a single row that has all 0 in a row or in a column, so the determinant will be 0. This is the second property. So let's see the third property. If two rows or two columns of a matrix are interchanged, then the sign of the determinant changes. Which means, suppose there is a matrix 1 2 3 4. Here there is 1 and 3, here there is 2 and 4. Suppose if I interchange this, like if 2 4 I written here and 1 3 I wrote here. So the determinant of both these will be same value, just it will be of opposite signs. So determinant of this will be 4 into 1 4 minus 6, 4 minus 6 minus 2. So now here I interchange the columns. I wrote 1 3 here, 2 4 here. So 3 to the 6, 6 minus 4 2. So there is only sign difference. Also if you change the rows, then also it is same logic, only there will be difference in sign, the value will be same. So the fourth property is if three rows or three column of a determinant are changed, then the sign doesn't change. That means if you just interchange this, like you row, this row you write here, this row you write here, so the value and sign doesn't change, it is always the same. The fifth property is determinant of A is equal to A transpose. That means suppose this is the matrix 1 2 2 2. Suppose if I take this row and write it in column. So 1 2 I write it in column 1 2, 2 2 I wrote in column. Here it is in row form, I wrote in column form. So if I calculate the determinant of this, so 2 into 2, 2 minus 4, it is minus 2. And after changing the position, like 1 2 I wrote here 1 2, 2 2 I wrote here 2 2. Then if I calculate the determinant value, it will be also same. So changing the positions of rows or column doesn't change the determinant value. So it is A equal to A transpose. This T is transpose. This is a property of the determinant. See, here is the proof. So here I took 1 2 3 3 2 2 1 2 2. So when we calculate the determinant value, it comes as 4. So now I change. Now I will write it transpose. So in transpose, we just write the row in column and column into row. So here we'll write the row into column. So 1 2 3, I write here 1 2 3 3 2 2 3 2 2 1 2 2 1 2 2. Just change the row into column. Then I calculate the determinant. It is also coming 4. So here determinant of A is also 4. Determinant of A transpose is also 4. So determinant of A is equal to its transpose. It is also equal to 1 upon A inverse. So A inverse is in future videos. The sixth property is, suppose there is a matrix 1 2 3 4 5 6. How do we call this a matrix? If it is bracket, it is matrix. If it is in mod, it will be determinant. So here it is in bracket, so this is a matrix. So if in this matrix I want to multiply a scalar quantity like any real number, so here it will get multiplied to every element of the matrix. See here, if I want to multiply 3 to A, it will get multiplied to every element here. So here I can take 3 outside as 3 cube and write this 1 2 3 4 5 6 4 for one remaining element. But in determinant, suppose there is a determinant A 1 2 3 4 4 1 1. If I want to multiply the scalar with to a determinant, it will be only multiplied to a row or a column. It will not be multiplied to every element. So here see, the 3 is multiplied to the first row only. I cannot multiply it to the second or third or the first or any column. It will be only for any row or any column. So for which column or row you want to multiply, it's your choice. So here let's say a numerical, there is a matrix. I want to multiply 5 to the matrix. So I want to calculate here determinant. So determinant 5 into a got determinant 5 cube. This 5 cube came, uh, no, here we have multiplied 5 to the matrix. So 5 will get multiplied to each and every element. So I can take 5 cube outside and write this 5 cube is 125 and determinant of A. So the determinant of A is the determinant of this matrix. So 125 into delta. So here there is a matrix A 5 cross 5 and it's saying the determinant is 5. And they have given a matrix B is equal to 5 into A, matrix is equal to 3 into matrix B. They are saying calculate the determinant of B and determinant of C. So determinant of B is 5A. So for this there is a formula, that is, if you want to multiply a scalar quantity to a determinant, to a matrix which is of n cross n, it is square matrix, into scalar into determinant of A, this is equal to k raised to n into determinant value. So suppose the ke here is 3 and n here is 2 cross 2. You just write 3 raised to 2 and the determinant. So here the n is 5 and the scalar is 5. So you just write 5 raised to n which is 5, and the determinant value is 5. So I wrote 5 here. So 5 raised to 5 into 5, which is 5 into 5 plus 1. So here the power is 1. So a raised to m into a raised to n, which is a raised to m plus n. This is the property. A raised to m into a raised to n is equal to a raised to m plus n. So 5 raised to 6, which is some value. Now they want, so we got the determinant of b. Now they want determinant of c. They have given determinant of c is equal to 3 into b. This b is determinant. So here 3 raised to 5, since 3 is the scalar quantity and n is the order. So 3 raised to 5 into determinant of b is equal to 3 raised to 5 into determinant of b is 5 raised to 6, and this is the value.